All right, here we go. Today in bell work, we're working through a free response or a multiple choice question, an easy one if you know what you're doing. Okay, but you got to know what you're doing first. The temperature of a room at midnight is 20 degrees Celsius. Over the next 24 hours, the temperature changes at a rate modeled by this differentiable function h. So h of t is degrees Celsius per hour. That is the change in temperature. Okay? Which of the following is the best interpretation of the integral from 0 to 6 h of t dt? Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you got? 1 for A, 2 for B, 3 for C, 4 for D. Getting mostly the same answer. I have an integral of h of t. What is h of t measured in? I'm integrating degrees Celsius per hour from 0 to 6. Thinking of units is going to be very important. If I integrate degrees Celsius per hour, what are my units going to be when I actually integrate it? Degrees Celsius. Okay? And so it is not the temperature of the room at 6 a.m. That's not what it's telling me. Okay? When I integrate, the whole idea with integration is it is going to tell you the change of the temperature in the room in degrees Celsius. Okay? Between two bits of information. If I'm integrating, it's telling you a change over time. That is the change in the temperature of the room over time. That is what is going to happen there. Okay? The rate at which it's changing, no, that's h of t. Okay? This thing right here would just be h of t. To find the temperature of the room, what you would do is you would take the 20 degrees that you started with, and you would add to that the change in temperature, or the change in temperature over time. That would tell you that one. How would I find, talk with your neighbor, how would you find the average temperature of the room in degrees Celsius? Think about that for a second. How would you find the average temperature of the room in degrees Celsius? We are trying to find the average of the temperature of the room in degrees Celsius between midnight and 6 a.m. This one's kind of tricky. Anyone confident in what they said? If I want to know the average temperature, we talked about integration and finding averages. What am I going to have to integrate to find the average temperature? Kind of. I am going to need a divide by 6 in front. You're not wrong. But I can't integrate h of t. If I did this, what would that tell me? This right here, 1/6 h of t. H of t is the change in temperature at a rate. That's the rate of the temperature. That's how much the thing is changing. So this is going to tell me the average change in temperature, okay? Because it's going to find the average of whatever I integrated. And so if I wanted to find b, I would have to have another function like g of t. I don't know even what it would be, but some other function that would tell you the temperature in the room, all right? Not the change in temperature in the room. It's a little bit different. A little bit challenging there, but that's good. All right, let's get into what we're getting to today. Today's lesson is kind of strange. Okay, I'm warning you now. It's kind of strange as we do it. The good news is the way we're going to simplify it's going to make it really easy. Okay, this thing right here is called sigma notation. You remember seeing it before? Sure. If you've forgotten, it's not really tough. Okay, it's actually really easy. If I wanted to solve this problem right here, okay, this number on bottom is going to be your starting value. You're going to take this number and plug it in. So it'd be like -3 times 1, so it'd be -3. Then I increase it by 1. So I would plug in 2. So -3 times 2 would be -6. And then I increase it by 1, I would plug in 3. So if I plugged in 3, it'd be -9. And then I would increase it by 1, I'd plug in 4. -3 times 4 is -12. And I would stop, because this number on top is where you're going to stop at. I would stop at whatever that top number is. And then what do I do with these numbers? -3, -6, -9, and -12. Add them together. This is called sigma notation, or other words known as summation notation, which means you're going to take all of those numbers and add them together. Okay? That is what we're going to do today, that same exact idea. All right, so today we are doing Riemann sum definite integrals, or a better description of what we're doing today is we are writing integrals, okay? So we're going to change this idea right here, like 3 to 6, h to t dt, like we just did. And we are going to write that in sigma notation. It's going to involve limits. So remember how much you loved writing the limit definition of a derivative? Yeah, you're going to love it about as much as you love writing the limit definition of an integral. Okay. The good news is every time we do this problem today, it's going to be multiple choice on the AP exam. And by the end of the day, you're going to be really good at multiple choice. Okay. So it's not like I'm going to make you do a ton with it. You're going to be fairly decent by the time we get done. All right. So what we're doing is we are showing the area under the curve. Okay. We've done that so far using summation notation or using Riemann sums. Okay. Like for example, I could break this guy into 2 rectangles. How good of a representation is that of the area under the curve? Not good. Decent, but kind of bad. What if I broke it up into 5? Is that better? Yeah, if I had more rectangles, there's less empty space. If I broke it into 10, better. 100? Best. What would actually be the best? Infinite. Okay? If I broke up the area under the curve into an infinite amount of rectangles, that would be good because they would be almost just straight lines and it would tell me the exact area under the curve. Okay? I am going to add up. That's what we're doing today. We're going to find the sum of an infinite amount of rectangles. Okay? So here's how this works today. To find the area under the curve, we're going to find the limit where n represents the number of rectangles. Okay? It's going to be infinity every time. It's always going to say I equals 1 on bottom, but we're going to add up. That's what sigma means. That's what we just talked about. Sigma means the sum, and this is going to be over here, the area of the rectangles. How do you find the area of a rectangle? Base times height. That's what we're going to do. Okay? We're going to have an infinite amount of rectangles in the end, but it's going to represent that setup. It's kind of strange. Give me a second to talk through it. It will make more sense as we go. All right? So I love just jumping into an example. We're integrating from pi to 2 pi. Cosine x dx. I want to know first the width of the span that you're trying to integrate. From when to when am I going to integrate this thing? From pi to 2 pi. Everybody agree with me? So that's the first thing we're going to do. The first thing we're doing here is we're finding the width. Okay? The width of each rectangle is going to be your lower bound and your upper bound subtracted. So 2 pi minus 1 pi. Okay? Or just 1 pi. That is the span that you're going on your integral. You are always going to take that and divide it by n because you're going to divide it up into infinite amount of rectangles. Okay? So this guy right here, your width over n, that represents the width of your rectangles. Then we want to know the height. Okay, so understand what the height is. Like this thing right here is the height of this rectangle. To find that height, you're going to take whatever this x value is, and we would plug it in to some equation. Everybody somewhat agree with me? This x value, I plug it into the y equals equation, it would tell me the height. That's what we're going to do below. So to do that, you take a, which is your lower bound, plus the width. And then you get this I. The I represents which rectangle are you looking for? Are you looking for the first rectangle? Are you looking for the second rectangle? The third, the fourth, the fifth? It just depends. It gets a little bit crazy, but that's what we're trying to do. Okay, so for this problem, my lower bound is pi because of this right here. The width is this guy right here, and then we multiply it by I. If you take this thing and you plug it in to your equation, that's my equation, cosine x. If I plug it in for x, Just like that, this is going to tell me the height. This is going to tell me the width. If I take the height times the width and I add up all the areas, it is going to tell me the area under the curve. It's kind of crazy. We could spend days breaking down what that's going to be. Okay, it'll make more sense as we go, and the more multiple choice you do, the better you're going to be. Okay, let's look at example A. Okay, or whatever this first one is. Which of the following limits is equal to this? Look at this. This is how it's going to look. I got some summation notation over there, some sigma notation. I'm finding the area of rectangle, so I want to know what's the width and what's the height going to be. Show me with your fingers, what is the span of your integral? What's the width of your integral going to be? Show me with your fingers, what's it going to be? It is going to be 3 because we are taking 5 minus 2. The width is 3, and we're going to divide it up into n amount of rectangles. So I'm looking over here, and I want to see this 3 over n being multiplied by something. That's the width. So which answers can I eliminate that do not have 3n times something? A and C. This one's got a 1n, this one's got a 1n. It's not those two. The height. To find the height, you are going to plug in your lower bound. What's my lower bound? 2 plus the width. In this case, it's not the letter I. They're using the letter K. Fine. So it's the width times K. And you're going to take that whole equation and plug it in to whatever you're trying to integrate. So I'm going to plug that all in to something squared. So it's going to be 2 plus 3K over n squared. So which one of those is the right answer, B or D? It is D. Maddie. 2 is my lower bound. Yep, I just wrote the lower bound. The lower bound was 2, so I put a 2 down. Other questions? You okay? It'll make more sense as we go. I know the first time it's not going to make a ton of sense. Let's flip it to the back side. That bottom one on the notes is actually the hardest one. Flip to the back side. We'll come back to that one. On the back side, it says we're practice writing these Riemann sums using definite integrals. Talk with your neighbor. Use that same idea. Flip back and forth if you need to. Which one of those matches with that integral right there? Talk to each other. Figure it out. Here we go. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you got? We're seeing some 3s. Let's just check. Cannon, what's the width of this thing going to be? 3 over n, because he's going from 0 to 3, and he always divides it by n. So he's looking for one with 3n in it. It's not A. It's not D. The height. You are going to plug in to this equation. You're going lower bound. So what's my lower bound? 0 plus the width times whatever letter they're using. They're using I here, so 3in. It's C. It's the only one that makes any sense. Kind of makes sense what we're doing. Height times width. Height times width. That's what we're doing each time. Let's look at the next one. Now I'm making you do it without multiple choice. We're going the other way. I'm giving you the sigma notation. You're trying to write it as an integral. Talk with your neighbor. You need the upper bound, you need the lower bound, and you need the equation. Try to come up with those 3 things. Go. Here we go. Let's see how we did. Show me with your fingers. What do you think the lower bound is going to be? Lower bound is going to be 3. A and B, why do you think it's going to be 3? Yeah, that number added in front is going to tell them the lower bound. That's where we're starting. Show me with your fingers. What do you think the upper bound is going to be? Caden, why do you think the upper bound is going to be 7? Yep, 3 is my lower bound, and that right there is how wide it's going to be. That's your width. So it's 4 across, so 3 plus 4 gets me 7. What about an equation here? Anybody have an idea on equation? What do you think, Max? X squared, because this whole thing is living inside of x squared. Questions on that one? Try the next, A, B, C, or D. Talk with your neighbor. Figure it out. Here we go. 1 for A, 2 for B, 3 for C, 4 for D. What you got? Taylor, where did you start here? The lower bound is first. So she's got this 4 out there. kind of be careful with that, and we'll see an example in the future. But yeah, I agree. Okay, lower bound of 4, so it's not A or B. What's your width is 5. Yeah, that should match what we got here. How did you know then, Taylor, that it was C and not D? Yeah, this is her lower bound here. If we already had this 4 here, then your number you would have in front would be an 8 because it's 4 plus the lower bound. That's not what we want there. It's going to be C. Yes, sir. It would be hard to work backwards. That's why we'd give multiple choice. So the question was, what if this number was an 8? How would I make that distinction? You would need some help. You would need some help with that multiple choice to try to work my way through it and be able to decipher, hey, this one doesn't make sense based on what we have. Okay, that leads us to our last one here. Okay, which of the following limits is equal to that integral? That's the toughest one. A, B, C, or D. Look at it, talk with your neighbor, figure out which one it is. Let's look. 1 for A, 2 for B, 3 for C, 4 for D. Little bit more challenging. I'm seeing some 1s, I'm seeing some 4s. Let's do it again. So we're talking about width, we're talking about height. Evan, what's the width of my integral going to be? 3. It's 3. And so he's looking for 3 over n somewhere in your problem. Which choice did you eliminate based off of that? C. It's not C, because C has 4 over n. The height. Now pay attention here. The height is going to be this. The square root of 1 plus 4, and then n for x is where I'm plugging in that lower bound plus the width. What's my lower bound? Well, that is 1. And the width is 3 over n times the letter I based on what they gave me. Everybody see what I'm doing there? I'm always plugging that into my equation. So far we've done it. It's always been a pretty easy equation. It's been something like x squared. This time it's a little bit more complex, but I'm plugging it in for x. I'm always plugging all of that in for x in my equation. So as I set this thing up, if I distributed that 4, it would be 1 plus 4 plus 12in. Or in other words, that number in the front would be a 5. That's where I'm getting a from. Would that be easy to work from this one backwards, Luke? No, it would. It would be pretty tough to go from this back the other way. But going to it isn't too bad. Questions on what we did? You will get better the more multiple choice we practice. Yes, ma'am.
Why did you distribute and
I distributed, so then it was just a big adding sign, right? So it's just 4 plus 1, and then I just combine like terms. Okay. Do you have a